Hello. In this video, I'm going to be going over graphing, specifically with linear functions. This is a huge piece for the Algebra 1 state test, so it is important that we understand how to graph. If you are needing some assistance with how to graph specifically points, please check out the first video in the graphing series, in which I go over how to graph a coordinate pair on our graph. So moving forward, we are going to be dealing with graphing linear functions. Now there are different forms that you can see for equations. I'm going to start off with the basic form, and then from there I will expand. The basic formula that you will see for linear functions is what's called slope-intercept form. That is y equals mx plus b. Again, this is called slope-intercept form. Now, this formula is given on reference sheets for the Florida Algebra 1 EOC. It is just not labeled as slope-intercept form, but you are given the formula itself. It does not explain what the formula represents. That is something you will have to know going into your test. So let's go ahead and do a little recap on what it does represent for us. In this equation, the y and the x will remain in the equation. So the y and the x will remain. But for our equations, you will notice that the m will change into a specific number as well as that b. So let's talk about the m first. The m is going to represent our slope, and that is why it's in the name, slope-intercept form. Your slope represents your rise over your run, meaning how much you are going up or possibly down over how much you are going left or right. Now with that up, down, left or right, that is going to depend on our sign, meaning if it is positive or negative. Now for our slope, you typically will see it in fraction form. If your top number is positive, that means you will be moving up. If your top number is negative, that means you will be moving down. In the denominator, if you have a negative number, that means you are moving to the left. And if you have a positive number, you'll be moving to the right. I will go over this again once we have an actual equation written, but just so you have it, if in case you were taking notes, wanting that extra recap of what sign means which direction. Now that B is going to represent an intercept. Again, it's a part of the name. M is slope, B is going to be an intercept. It is specifically going to be our y-intercept. Our y-intercept for us, you have your graph, it will be on the y-axis. So on that up or down, you will have a point somewhere that will represent your y-intercept. You can also see your y-intercept written as a coordinate pair or as a point. Again, check out that video if you need that recap on points themselves. But your y-intercept is going to be 0, your b value. So whatever that number is for b, that is the number that is your y-intercept, where you will put the point on the y-axis. All right, so we're going to go ahead and use a formula, use equation, and actually graph this. All righty, so we're going to go ahead and start off with the following equation. We are going to start off with y is equal to 2 over 3x plus 1. All right, so with this, the m is attached to the x. M again is that slope. Slope tells us our rise over run. Well, that is at 2 over 3. You can rewind if you need to check out the signs and the direction, but as a recap, if your top number is positive, that means you will be moving up. with your denominator, since it is a positive number, that means I will be moving to the right. Now, I like to indicate this first before I actually start putting things on the graph. What we need to understand is slope is telling us what direction to move from the y-intercept. So you should not be putting anything onto your graph yet when you are just looking at the slope. In order to start putting things on our graph, we are going to want to actually start off by looking at that y-intercept. So that b value, that y-intercept. Again, as a point, it will be 0, comma, whatever that number is. So for us, it's a 1 in this equation. Understanding how to put a point, well, 0, comma, 1, 0 on the x is right in the center. Again, that is called the origin. Then you would satisfy the y part of your point, meaning you would be going up to positive 1. Again, that y-intercept will always be on that vertical axis that is typically labeled the y. You will find that specific number. For us, it is positive 1, and I'm going to go ahead and mark it on my graph. So that is our y-intercept. That is our b. Only once you have put in that b can you now go and try to follow your slope. Slope is like steps that you're taking. So I need to take 2 steps up, given how I have a numerator of 2, and then 3 steps to the right. By a step, I mean you are counting boxes here. Again, you're going to have gridding. So you're going to count boxes, up 2 boxes, and to the right 3. You are more than welcome to make drawings when you're trying to do this. If you are taking the Florida Algebra 1 EOC, you will have graphing space in your workbook. So you can absolutely do these drawings by hand and then transfer it to the laptop. So I need to go up 2. So from that given point, I'm going to count up 1 box, up 2 boxes. So I'm counting that up 2. You do not stop and put a point here. This is only part of the steps. I need to make sure I'm following both top and bottom. So now from where I stopped, I need to follow that bottom direction, which is telling me 3 to the right. So then I will count to the right, 1 box, 2 box, 3 box. Only once we have done both of those directions will I now go ahead and mark where I have landed. Now that you have marked that final positioning, you can use a ruler if you're doing this by hand. If you're doing this on a test, typically it will automatically connect for you, but this will connect and make our line. Excuse my handwriting, this is not the most straight line, but it just connects and you have graphed a line. So again, always starting at our y-intercept, following your direction for your slope, and then connecting the 2 together. Now, to make sure we have done this correctly with putting the point on there, you could actually take another perfect point. So right here, I do see a perfect point. I'm going to go ahead and mark that for us. If I was to take this point itself, which would be 6, comma 5, if I was to plug in the x and the y into my equation where I have x and y, you would get a true statement once you simplified it down, meaning you would end up with a 5 on the left. Simplifying on the right, you would end up with a 5 as well. So there are ways you can check yourself with this graphing, but if you are just following the y-intercept, then your directionals, you will have a correct line. I'm going to go ahead and do another one of these just so we can see some extra problems. With this next one, I'm going to manipulate the slope, so it's going to look a little bit different, but just to make sure we understand some concepts. For this next one, we're going to use the equation y equals 2x plus 3. So for this one, our slope, our m, is always attached to that x, But for this one, I have just a whole number. All I have is the number 2. But before, I had a fraction. The fraction helped me clearly see the up and down in the numerator and the left and the right in the denominator. If you have a whole number, please help yourself out and make it a fraction. Now, how can I make a whole number a fraction? You will simply put a fraction bar and a 1 in the denominator, because 2 over 1, or 2 divided by 1, is the same equivalent as 2. But once we see it physically as a fraction, we will most likely not make an error with our directions, because I have definitely seen some individuals make errors if we do not make it a fraction. Help yourself out. Numerator, now I know it is positive, so I'm going up. Denominator, I put in that 1. I'm not randomly going to make it a negative 1 when I'm putting it in. It is going to remain positive, which would mean to the right. Again, you are not graphing anything when you start off by labeling your slope. That is just helping us for once we have our y-intercept. So for us, our y-intercept is that 3, meaning the point can be written as 0, 3. You always locate y-intercepts on the vertical axis. So I scan up and down till I find positive 3, and I'm going to go ahead and mark my point. Only once have we marked our y-intercept can we now follow our slope. So now I can follow my steps. I need to do 2 steps up and 1 step to the right. So I'm going to go ahead and make some markings. I need to count up. 1, 2, 2 steps up. I'm not placing a point there where I ended. I need to make sure I follow my denominator, which means 1 step to the right. Only once I have followed both of those directionals, now can I put my point on my graph. Again, if you're on a computer, typically it will go ahead and connect for you. Otherwise, if you're doing it with a paper and a pencil, hopefully you would use a ruler and you would connect. And then we have our line. All right, so with both of these examples that I gave, they were both positive slopes. With the negative slopes, it's going to be a very similar process. The only difference is you would be going down and then to the right. So let's go ahead and see an example with a negative slope. We're going to go ahead and use the equation y equals a negative 1 over 3x. And I'm going to go ahead and make our y-intercept negative. I'm going to say negative 2. Here we go with labeling, starting off with our slope. Slope is the negative 1 over 3. Now I do want to go ahead and make a note here so we are aware. Sometimes with given tests, they might put the negative in the middle, meaning right alongside the fraction. If you are given something like this, please alter it to help yourself and just move it into the numerator. They are the same equivalent. If you leave it in the middle, I can guarantee you're going to accidentally make a mistake and give both of them the negative. Move the negative to the numerator if it is written in the middle. That's just a little side note. But with this, understanding directions, top number is either up or down. Well, negative now means I'm going to be moving down when I'm counting. That positive 3 in the bottom means I still am going to the right. The only time I move to the left is if that denominator had a negative number. Again, not graphing yet. I've just labeled my slope to help me. Then I can move to my y-intercept. Well, for this one, our y-intercept is going to be that negative 2. As a point, 0, negative 2. We search up and down our y-axis, finding negative 2. It will be below 0. So I'm starting down here this time. And I still follow my directions like steps on a staircase. I need to count down 1. So from that point, I'm going down 1. I'm not placing a point there yet. I need to make sure I follow my denominator. My denominator says to the right 3. 1, 2, 3. Only once I have followed both, now I can go ahead and make a marking for my point. You have your 2 points. You could go ahead and connect. So notice for slopes, a positive slope will be going up and to the right. Negative slopes are going down and to the right. All right, so this is how we graph a linear function in slope-intercept form. Now, there are other forms that you can be given as well in problems, including point slope and standard form. My advice that I give to you as a student who's needing to prepare for exams, always get your equations into slope-intercept form and graph from here. You are less likely to make errors if you become super common with the one specific formula in terms of what it represents for a graph. I'm going to be making a separate video down the line regarding the 3 different forms and how we can make them all into the most common one, which is that slope-intercept form. So if you have any other form, we are wanting to change it to slope-intercept form by getting the y alone. All right, thank you for watching this video regarding how to graph our linear functions, specifically with slope-intercept form. Catch the next video where I'm going to be going over graphing with some of our other functions, which include exponential as well as quadratic.